Welcome back everybody to another video. I'm a teacher from ILM Online Academy and today we have the IGCSE Chemistry Revision Notes. As you already know that there are 22 chapters which are included in the IGCSE Chemistry for the code 0620, and in today's video we'll talk about the third chapter of our book, which is about the chemical bonding. You can see on my screen the highlighted one. This is the third chapter of our book, which is about the chemical bonding, and the contents which are included or which we will discuss today under the chemical bonding is non-metallic substances and the covalent bonding. Second is about the ions and the ionic bonding, and third is about the giant structures. So let's start. So first of all, you should know about the chemical bonding. Chemical bonding are the strong forces that hold the atoms together in the various structures that chemical substances can form. So we have different types of the chemical bonding which we will discuss in today's lecture. First is about the metallic bonding. First we have the metallic bonding. These are the different types of the chemical bonding which we will discuss today. Second we have ionic bonding. And third we have the covalent bonding. These are the three main types of the chemical bonding which we will discuss today. Chemical bonding are the strong forces that hold the atoms together in the various structures, and chemical bonding involves the bonding between the outer electrons that are present in each atom, like as we have done in the chapter number 2, the outer electrons. Chemical properties or the physical properties of the different atoms, they depend upon the different structures. So chemical bonding is depend upon the outer electron that are present in any element. For example, we have the example of the lithium atom. Lithium has 3 electrons, 2 are present in the inner shell and 1 electron is present in the second shell, or the valence shell you call it as, or also as the outer shell. So just outer electrons are involved in the chemical bonding of the lithium, not the inner electrons, or not protons and neutrons are also not involved in the chemical bonding. Generally speaking, there are 2 types of compounds. First we have the 2 types of compounds. First are the First we have the molecular compounds where atoms are bonded together. First is the type that is known as the molecular compounds, in which atoms are bonded together, and the examples are water, H2O, ammonia, NH3 and methane. All these are examples of the molecular compounds in which atoms are bonded together. We have studied about the atoms, elements, compounds and mixtures in our previous video, which is related to the chapter number 2, states of matter, and now where atoms are included or where atoms are related, those are known as the molecular compounds. And the second type of compounds are known as the ionic compounds, in which different ions are present, where many ions or charged atoms are held together in the regular structure. So the examples of these are NaCl, sodium chloride. So first of all, the question arises that the formation of the ions, or how ions are formed. So I will tell you about the formation of the different ions first, how ions are formed. Formation of ions. Ion is an electrically charged atom or the group of atoms that is formed by the loss or gain of electrons. So first, by the loss or gain of electrons, we get the ions. Ions are basically, first of all, they are the atoms or the group of atoms. When the atoms loss or gain electrons, they form the cation or the anions. These are the 2 different types of ions. Cations, these are the positively charged, and anions are negatively charged ions. Anions are negatively charged and cations are positively charged. I will give you the example of the cations and anions from this example, lithium. As lithium has just 1 electron, so lithium will form the cation as Li positive when it loses its outer electron. So now lithium has just 2 electrons in the inner shell, and the outer shell is removed because there are no electrons that are present when lithium forms the lithium ion or the lithium cation. So this is the example of the cation. And if we talk about the anion, we have another example, which is chlorine. This is the structure of the chlorine. Chlorine has, in the first shell, chlorine has 2 electrons. In the second shell, chlorine has 8 electrons, like this. And in the third shell, total chlorine has 17 electrons. In the third shell, chlorine has 7 electrons. When chlorine gain 1 electron, like this, that is shown by the cross, you can see here. So now this forms the chloride ion Cl negative, and now this is the example of the anions. So when atom loses the electrons, they form the cations or the positive ions. Now I will give you some hint related to the cations. You can see here that the T that is present in the cation, that represents the positive charge. So this is the hint for the cations, and anions are for the negatively charged ions. Cations are formed when it loses the electrons, and anions are formed when they gain the electrons. So this is related to the formation of the cations and the anions. You can see here, first shell has the capacity of 2 electrons, holding 2 electrons. Second shell has the capacity of holding 8 electrons, and third shell, all the subsequent shells have the capacity of holding the 8 electrons. So what will happen here? As chlorine has 7 electrons, so chlorine, there is a space for one more electron in the chloride ions. So what will happen here? It is easier to gain the 1 electron than to lose the 7 electron to achieve the full outer shell electronic configuration, or just like the noble gases. So that's why chlorine gained that 1 electron and formed the chloride ion. So this is the formation of the negatively charged ion. All the metal atoms lose their electrons to the other atoms to become the positively charged ions. Metals are included in the category of cations because metals have free electrons, they donate their electrons, and all the non-metals gain electrons just to complete the valence shell because they don't have more free electrons to donate them, so they form the anions. So these are the examples from our periodic table, that metals form the cations and non-metals gain the electrons to form the anions. So electrons are transferred from one atom to another atom, forming the ions that can be cations or that can be anions. So the ionic compounds are held together by the electrostatic forces of attraction between the oppositely charged ions. So this is the basic information or basic formation of the ions, how ions are formed, and these ions are responsible for the ionic bonding. I explain to you the formation of the ions, how ions are formed. So these ions are responsible for the ionic bonding, how ionic bond is formed. Now I will give you an example related to the ionic compounds, like how ionic compounds are formed. First of all, we will discuss about the ionic bonding, which is held together by the electrostatic forces of attraction between the oppositely charged ions, and then we will discuss about the covalent bonding. So let's start the ionic bonding. Now we have the ionic bonding, or how ionic compounds are formed. Let's take an example. In the group 1 of our periodic table, there are metals that are present there, and these metals will lose their electrons. They have just 1 electron because they are present in the group 1. In the previous video, I told you about that there is a specific representation of the group number and the period number. Period number represent the number of the shells that are present in any atom, and the group number represent the number of the outer electrons. So the group 1 elements have just 1 outer electron that is present there. So they lose their electrons to form an ion that is known as the cation. For example, we took the example of sodium first. In the group 1 we have sodium, and sodium has total 11 electrons that are present in the atom. This is the structure of the sodium. In the first shell we have 2 electrons, in the second shell we have 8 electrons, in the third shell we have just 1 electron. So what will happen when sodium forms the cation? It loses that electrons, and when sodium loses that electron, now it has just 10 electrons. Now sodium has just 10 electrons, 2 in the inner shell and 8 in the outer shell, like this one. So this is the sodium cation that is formed. Sodium is present in the group 1. Sodium ion has now single positive charge because it has now just 10 electrons in the total, but there are 7 protons that are present in the nucleus of an atom. That's why a positive charge will be assigned to the sodium. Now take the example of the non-metal. This is the example of the metals. Ionic compounds are formed, or ionic bonding is present between the metals and the non-metals. You should know that this is the type of bonding that is present between the metals and non-metals. So we have taken the example of metal. Now we'll move towards the non-metal to show the bonding between the different atoms. First we have given the example of metal, which is the sodium from the group 1. Mostly ionic bonding are present between the group 1 and the group 7 of the periodic table. Group 7 are the halogen atoms. In the group 7 we have halogen atoms, and group 7 means they have 7 electrons that are present in the valence shell or the outer shell. They just need one more to complete the valence shell or the outermost shell. So the group 7 has 7 electrons in the valence shell. They can achieve a stable noble gas configuration by gaining an outer electron. So we have an example of chlorine. Chlorine has 17 electrons, 2 in the inner shell, 8 in the second shell and 7 in the third shell, like this one. So chlorine requires one more electron to achieve the stable electronic configuration. So what will happen? Chlorine will form the chloride ion by the gaining of that one electron. This is an example of non-metal. So ionic bonding is present between the metal and the non-metal, because metal atoms loses the electron and non-metals gain that electron. That's why this bonding is present between a metal and the non-metal. Now we have the sodium ion and the chloride ion. Sodium ion has an A positive charge and chloride ion has Cl negative charge. So positive ions are known as cations and negative ions are known as anions. So this is the bonding that is present between the non-metal due to the electrostatic forces of attraction that are present between the oppositely charged ions. So ionic bond is present between the sodium and chlorine because of the electrostatic forces of attraction that are present between the oppositely charged ions. Oppositely charged ions always attract each other and same charges repel each other. So because of the opposite charges that are present on these two atoms, they attract each other and they form the bond which is known as the ionic bond. So this is the example of the ionic bond that is formed between the NaCl. Next we can also call it as the compounds that are formed between a metal and the non-metal, that they involve the ionic bonding, and this is by the transferring of electrons. An electron from the sodium is transferred towards the chlorine. That's why the bond is formed. So in case of ionic bonding, electron is transferred from one atom to another atom and they form the ions, cations and the anions. Then ionic bond is formed between these two atoms. So now I will share some important features which are related to the ionic bonding. The important features which are included in the ionic bonding. The first one is, this type of bonding is present between the metals and the non-metals, metals and non-metals. This type of bonding is present in metals and non-metals. Second, electrons involved in the formation of ions are outer shell electrons. Outer electrons are involved into the bonding. Always outer electrons are involved into the chemical bonding. Metals form the cations and non-metals form the anions. Cations are formed by the metals because of free electrons that are present in their structures, and anions form the non-metals. And next ionic bonds result from the electrostatic forces of attraction between the oppositely charged ions. So there should be an electrostatic forces of attraction that is present between the oppositely charged ions, then ionic bond are formed, or ionic compounds are formed between the different atoms. So these are the important features that are included into the ionic bonding. Next we have some physical properties which are included in this one. Now we'll discuss some physical properties of the ionic compounds. Ionic compounds are different to the covalent and the metallic compound because of the type of bonding that is involved here is different. They have high melting and boiling points. High melting and boiling points. Why ionic compounds have melting and boiling points? Just because of the electrostatic forces of attraction or strong forces of attraction that are present in their compounds or into their bonds. That's why we require a lot more energy to break the bond that is formed or to separate them. That's why they have high melting and boiling points. They are crystalline solids. Mostly, as maybe you observe the structure of the sodium chloride, that they are crystalline solids means they are solid at the room temperature. There is a regular arrangement of the ions with the opposite charges that are next to each other. They are soluble in water. Mostly all the ionic compounds are soluble in water, and when they're soluble in water they are separated into the different ions. They are often soluble in water but not soluble in another organic solvents, for example ethanol or something else, because water is attracted to the charged ions and therefore many ionic solids dissolve there. Next, the last property or the physical property related to the ionic compounds are they conduct the electricity in the molten form or into the solution form. These are the two forms of the ionic compounds when they conduct the electricity, into the molten and also into the solution forms. When they are solid, ions are held each other that they do not conduct the electricity in the solid form, but when they are dissolved into the solution or when they are in the molten form, when they are heated or converted into the molten form, they conduct the electricity, because in the liquid or in the solution ions are free to move about. They can move towards the electrodes when the voltage is applied, but when they are solid they are held together into the regular arrangement of lattice. That's why they do not conduct the electricity. So these are the important properties which are included into the ionic compounds. Hope you all know about the ionic compounds. Next we'll discuss about the covalent compounds. Now let's discuss about the covalent bonding. Covalent bonding is a type of bonding that is involved for the non-metallic elements. As we have read about, the ionic bonding is between the metals and the non-metals, but for the covalent bonding it is involved just for the non-metallic elements that are present in our periodic table. For non-metallic elements of our periodic table, this is a type of bonding that is specially designed for these elements. Like for example, the molecules that are present in our periodic table, you can see that the atoms that form the molecules like hydrogen that form the diatomic molecules, oxygen that form the diatomic molecules containing different types of H atoms, H2, O2. So in this we have a specific type of bonding, we call it as a covalent bonding, that is formed by the sharing of electrons, and these are for the non-metallic elements. This is a type of chemical bonding that is formed by the sharing of one or more pair of electrons between the two atoms. So by the sharing of electrons between two atoms, this is the basic definition of the covalent bonding, sharing of electrons between the two atoms, one electron from one atom, another electron from the other atom. So one bond is formed, and one bond refer to one pair of electron that is shared between the two atoms, and that electron and those electrons are considered in both. So one pair of electron and one electron from one atom and one electron from other atom is being shared in this one. So this is the type of bonding that you can see into the hydrogen, oxygen, chlorine, carbon dioxide. All these atoms are all these bonding are the example of the covalent bonding. So now I will share with you, for example, this one, hydrogen. As hydrogen has just one electron in the outermost shell, hydrogen is a non-metallic element. When two hydrogen atoms react together, they form the covalent bonding, and this is shown by the dot and cross diagram. This is the diagram that is used to represent the bonding in a molecule. Electrons in a 9 and also the outer electron that are shown here, they are represented by the dot and the cross depending upon which the atom they are formed. So in case of the dot and cross diagram, we show the electrons of one atom with the circle and the other atom with the cross, dot and cross. So what will happen when these two atoms form a bond, or they form a covalent bond? Their shells overlap like this. Their shells overlap, and the electrons that are present there, they are present in this overlapped area. So this is the structure of the hydrogen molecule. This is the hydrogen atom. This one is also the hydrogen atom. But when it forms a molecule, it is known as hydrogen, and the formula will be H or H. This is the bond that is present in it. This is the covalent bond. This is formed by the sharing of the electrons, and one pair of electron is present in this bond. One bond shows there is a one pair of electron that is present here. One electron from one hydrogen atom and other electron is from the other hydrogen atom. One more example I will share with you related to the covalent bonding is, this is the single covalent bond, as you can see here. One more thing about this, this is the single covalent bond that is formed into the hydrogen atom, just one. One more example of this type of covalent bonding is methane. This one, this is the structure of the carbon. Carbon has total 6 electrons. In the first shell we have 2, in the second shell we have 4 electrons, like this. So carbon needs 4 more electrons to complete the valence shell. What will happen in case of methane? 4 hydrogen atoms will come together with the carbon. When they come, this is the hydrogen atom. Hydrogen has just 1 electron, so when hydrogen will come nearer to the carbon and forms a bond, they form the covalent bond because both are non-metals, and the shell will overlap with this, like this one. This is the hydrogen atom, and their atoms are present there in this overlapped area here. This is the atom electron of the hydrogen, and this is the electron of carbon. So for this we have 4 hydrogen atoms like this. Now you can see here 4 bonds are formed with 4 hydrogen atoms. So this is the structure of the methane molecule, in which we have 4 hydrogen atoms and 1 carbon atom. Carbon needs 4 more electron. 4 hydrogen atoms will come nearer to this, and they form the 4 single covalent bonds with the carbon. This is also the example of single covalent bond. Next I will show you the example of the double covalent bond. In case of double covalent bond, we have the example of oxygen. 2 oxygen atoms come together. As oxygen has total 6 electrons into the valence shell, oxygen has total 8 electrons, 2 in the inner shell and 6 into the outer shell. So what will happen here? 2 and 6 into the valence shell, like this. This is the first oxygen atom, so there should be a double covalent bond that is present into the oxygen atom, because oxygen needs 2 electrons into the valence shell. One more oxygen atom will come and it will form the bond like this one. This is another one that come near to the oxygen and forms the double covalent bond. Now you can see here both the oxygen atoms need two more electrons to complete the electronic configuration, or to get the stable electronic configuration, just like the noble gases. These two oxygen atoms will form the double bond between them. Two electrons are shared, or two pair of electrons are shared. Two electrons are shared from each oxygen atom to form the double covalent bond. What will happen? They overlap. What will happen? They overlap. The outer shells are overlapped with each other, and two pair of electrons are being shared with each other. So double covalent bond will be formed. You can see here, this is the structure how the covalent bond is shown between the two oxygen atoms. These two oxygen atoms will share two electrons, two from each and two from the other one, like this one. This one. So a double covalent bond is formed between the two oxygen atoms. This is the example of the double covalent bond. Next we'll move towards the triple covalent bond. Triple covalent bond is present into the nitrogen molecule, because nitrogen N2, in case of N2, triple covalent bond is present between these two. Nitrogen has total 5 electrons into the valence shell. Nitrogen has total 7 electrons, 2 in the inner shell and 5 into the valence shell. So nitrogen needs 3 more electrons. So 3 bonds are formed into the nitrogen atom, and after the formation of the 3 bonds, this is known as, or this is the example of the triple covalent bond. So these are the main features of the covalent bonding. That the sharing of electrons. Sharing of electrons is the first one. Sharing of electrons happen in case of covalent bonding, but in case of ionic bonding, transfer of electron. In case of each atom contributes to the one electron is contributed by each atom to form the each bond. One electron by each atom. Or third one is molecules are formed from atoms that are linked to each other by the covalent bonds. So these are the main features that are present in case of covalent bonding. So this is the this is all about the covalent bondings. Next I will show you about the physical properties which are present into the covalent bonding. First of all, the physical properties. First we will discuss about the melting and the boiling points. They have low melting and boiling points. Why low melting and boiling points? Just because of that they are made up of simple covalent molecules. The forces between them are very weak, so not much energy is required to move the molecules further apart. That's why they have low melting and boiling point, because electrons are not transferred here. Electrons are shared between the two atoms, so they can easily overcome. They are weak. They are the intermolecular forces. So they are often liquids and solids at the room temperature. They are liquids and gases at the room temperature, but ionic ones are solid at room temperature. That's why they have low melting and boiling points. Solids have high melting and boiling points, liquids have low, and gases have much lower melting and boiling points. Third one is they do not conduct the electricity, because they are formed by the non-metals. This is the type of bonding that is specifically between the non-metals, so they do not conduct the electricity. There are no free electrons or ions that are present to carry the electrical current. There is one specific reason why electricity is conducted between the different atoms, just because of, first, by the free electrons, second, by the presence of the ions to carry the electrical charge or the electrical current that is present in it. So this is all about the covalent bonding or the covalent compounds, the physical properties, and also the important features that are present in it. Next we'll move towards the metallic bonding. and then we will discuss about the giant structures that are present in the metallic bonding, ionic bonding, and also in the covalent bonding. So let's move towards the metallic bonding. Okay, so now this is the third type of bonding that we will discuss today. This is about the metallic bonding. Ionic bonding is between the metals and the non-metals. Covalent bonding is specifically for the non-metals, and metallic bonding is related to only metals. Metallic bonding is the electrostatic attraction. This is also the electrostatic attraction just like the ionic bonding, but there is one difference between them is ionic bonding is present between the metals and the non-metals, but metallic bonding is present between the only metals. So this is the electrostatic attraction that is present between the positive ions in a giant metallic lattice and also with the negative ions or the electrons or the mobile electron that are present there. So first of all, I will show you a structure that represents the metallic bonding. This is the surface, or this is the structure of the metallic bonding, in which different metal atoms are present there. These are the metal atoms like this. There are thousands of metal atoms that are present there. This one. So what will happen, as you already know that metals have a specific property that they can lose electrons easily and form the cations. So what will happen here, in case of metallic bonding, we have different metal atoms that are present in this specific area. Metals have electrons in their outer shells, very few electrons in their outer shells, and when they are packed together, each metal atom loses its electron into this sea of electrons. So electrons are lost by each metal atoms and they form the cations, as you can see here. So now metal atoms will form the cations. By losing the electron, the metal atoms are no longer electrically neutral. They become the positive ions because they lost the electrons, and when they lost the electrons, they form the cations. And the number of protons in the nucleus has unchanged, but electrons are lost. So the structure of metal is made up of positive ions that are packed together. These ions are surrounded by the electrons which can freely move. These electrons can freely move here and there. There is no restriction that is present on the electrons, that they are not restricted to orbiting just one positive electron. They can be moved into this area. So that's why we call it as the delocalized electron. This is a specific word or special name that is given to these electrons, that is known as delocalized electrons, that is present in this sea of electrons where they can move everywhere. Right, so that's why it is known as the metallic bonding. We have the positive ion, positive metal ion that is present there, and the negative electrons that is present there, and it is present in this sea of electrons or the delocalized area that is used for the free or the mobile electrons between the positive ions into this metallic structure. So this is the structure of the metallic bonding, or how metals can conduct the electricity. Just because of these free electrons, electric charges can be carried out through that surface of area. For example, if we apply the electric current through this, electrons that are present there carry the charge from one surface to another, or you can say that from left to the right, and they carry the electrical charge. When they carry, then metals can easily conduct the electricity. So this is about the structure of the metallic bonding, or how metals can conduct the electricity. Next we will discuss about the physical properties. The physical properties that are present into the metallic bonding. The first one is the most common, and you all know about this. The first property related to the metals, that they are good conductor of electricity. Why they are good conductors? Just because of the free electrons that are present there. All the metal atoms have free electrons, and just because of those free electrons, metal can conduct electricity, because mobile electrons can move through the structure carrying the current. These mobile electrons will carry the current and move through the structure. This type of bonding is present in the alloy as well. Take a alloy, for example, we have the brass, we have the example of solder. All these are the examples of alloy, and alloys are the mixture of different metals. Alloys are the mixture of different metals, and this property is also present in the alloys. Second property, physical property related to the metals, are that they have high melting and boiling points. Why they have high melting and boiling point? Just because of the electrostatic attraction that are present in it, because of the positive and uh, positive ions and negative electrons attraction. That's why they have high melting and boiling points, because a large amount of energy is needed to overcome the strong forces of attraction between the positive metal ions and the sea of electrons. These attractive forces can only be overcome when the temperature is much higher. That's why they have high melting and boiling points. Third, they can be easily bent into different shapes, that is known as malleability or malleable. Metals are malleable, that they can be bent into the different shapes like the sheets. And the second is about the ductile. Metals are also ductile, that can be drawn into the different wires like the copper wires, as you have seen this. So metal can easily bend, their metals are soft, they can easily bend and shaped into the different structures, like first the sheet, which are malleable, and ductile, which are drawn into the or stretched into the wires. Metal lines are arranged into the different layers, like you can see this is the structure which I will show you, that when the that metals are arranged into the different layers, like this one. These are the metal atoms that are present in any substance, like this. This is structure of any metal. So when force is applied to this surface or just to this layer, there are layers that are present. When a force is applied to a metal, the layers can slide over each other without the structure being changed. So when we apply the force here, okay, you have seen here this one, there's the sliding movement. The layers can slide over each other, and now new bonds are formed here. These new bonds are formed just because of that the opposite attraction between the positive ion and the negative electrons. So that's why metals are easily bent and shaped into the different structure, as the malleability and also about the ductility. So metallic bonding is all about the metals. We have done with the properties of metals. First, good electrical conductivity. Next, we have the high melting and boiling points. Third, which is about the malleability and the ductility. These are the important properties which are included into the metallic bonding. So now let's have a look at the giant ionic structures and also with the giant covalent structures. First, we'll discuss about the giant ionic lattice. I will show you the structure of the giant ionic lattice. Let me do it. So you can see on my screen, ionic compounds form the lattice consisting of the positive and the negative ions. In an ionic lattice, the nearest neighbors of an ion are always of the opposite charge. So in sodium chloride, you can see here the sodium ion is surrounded by the 6 chloride ions. Here the sodium ion is surrounded by the 6 chloride ions. In this, we have the sodium ion that are present in the yellow, and chloride ions. Chloride ions are always on the corners, and each chloride ion is also surrounded by the 6 sodium ions. So there are equal number of sodium and the chloride ions, and the charges are balanced. So the actual arrangement of the ions in the other compounds also depends upon the number of the ions involved. And however, it is important to remember that all the ionic compounds are electrically neutral. That's why they are surrounded by equal number of opposite and negative charges. Chloride ions gain 1 electron and sodium ions donate that 1 electron, as you can see here, and then this will form the giant ionic lattice, which is the sodium chloride. So this is the arrangement of the positive and negative ions that are present there. Ionic crystals are hard but much brittle than other type of crystals. This is the result of the structure of the layer pushing one layer against another. this one. By applying the force or by pushing the one layer in this ionic lattice or ionic structure, what will happen? Against one layer against another, ions bring off the same charge next to each other. When there is a when same charges are present, there is a repulsion forces, the layers will move apart. So this can disrupt the ionic lattice. This can disrupt the ionic lattice just because of when one layer is forced or slide over each other. So ions in solution are able to move, so the solution can carry the electric charge. So this is a arrangement of the structure of the giant ionic lattice that are present into the sodium chloride. Ionic crystals are the giant structures because the structures repeat itself in all the directions, and the forces involved in this are same, holding the whole structure together. So we have giant ionic lattice and also the giant covalent lattice. Giant ionic lattice is a lattice that is held together by the electrostatic forces of attraction between the positive and the negative ions. You can say that giant structures or the giant ions are just because of the increase in number or more ions are present there. Just like the giant structures, there are lattice where the structures repeat itself in all the direction and the forces involved are same in all the directions. So this is the example of the giant ionic lattice. Next we'll move towards the giant covalent. So now we have the giant covalent structures. Giant covalent structures is a substance where the large number of atoms are held together by the covalent bonds, forming a strong lattice structures. And these are held together by strong covalent bonds that are present there. Strong covalent bonds are present in case of giant covalent structures. And large number of atoms are present in case of giant. Giant means a large number of atoms will be present there. So this type of structure is shown by the elements. For example, we have the example of carbon. Carbon is an example of the giant covalent structure in which we have in the form of different allotropes. Like the first one is diamond. Diamond is an allotrope of carbon, and also the graphite, second one. Graphite is also an allotropic form of the carbon in which we have seen the giant covalent structure which is present in this. And also some more compounds can also show the covalent structures, which is silica, SiO2. This is the formula of silica. So first of all, we will discuss about the diamond, the graphite, which is the allotropic form of the carbon. You can see on my screen, this is the allotropic form of carbon, which is the diamond. Diamond has very high melting and boiling points because of its structure. Diamond is very hard in structure because the bonding extends throughout the whole structure. It is very hard and it is also used for cutting tools. The bonds are rigid. The bonds that are present here are rigid and hard. That's why each carbon atom is attached to the 4 other more carbon atom. You can see here from this structure, the circle one shown the carbon atoms like this. This is the carbon, this one is the carbon, and each carbon atom in present that is here is attached to or make a bond with 4 more carbon atoms like this one. So 4 more carbon atoms are present. Carbon has 4 electrons in the valence shell and 4 more are required to complete the valence shell. So what will happen? 4 more carbon atoms will join in diamond with the 1 carbon atom. So the whole structure, you can see here, all the outer electrons of the atom in these structure are used to form the covalent bonds. There are no free electrons that are that can be able to move in case of diamond. So diamond is a non-metallic element. Diamond is the example of the non-metallic element in case of the carbon. Diamond is formed by the covalent compounds between the carbon, okay, and each carbon atom is bonded to 4 more carbon atoms. All outer electrons of the atoms are used to form the covalent bond, so therefore it is a non-metallic element and it does not conduct the electricity. Diamond is colorless. Diamond is a transparent liquid. It is used in jewelry and also in the ornaments, right? Diamond is the hardest natural substance that is present on the earth, and it is used in drills, diamond saw, and also the glass cutters. Diamond does not conduct the electricity because there are no free electrons that are present in the structure of diamond, because one carbon atom is bonded with 4 more carbon atoms. Now all the electrons are completely filled, or now they have the stable electronic configuration. Electricity will be conducted in 2 cases. First, because of free electrons, second because of the ions. So there are no free electrons in the diamond, and the diamond will not conduct the electricity. So this is the giant covalent structure or the allotropic form of the carbon, which is shown here in the form of the diamond. Next we will discuss the second giant covalent structure of the carbon, which is the graphite, and also some compounds also show the giant structures, which is the silicon oxide, SiO2. First I will show you about the graphite, so let's move towards the graphite. One more thing about diamond is that it has the tetrahedral structure that is present in case of diamond. Diamond has tetrahedral structure. How tetrahedral structure? Because all the carbon atoms that are present here are bonded to 4 more carbon atoms, so there is no free electron that is present here, so the tetrahedral structure is present in case of diamond. Now let's move towards the graphite. Hexagonal structure is present in case of graphite, and you can see here in this example of the graphite, each carbon atom is bonded with just 3 more carbon atoms. You can see here every carbon atom will make a bond with the 3 more. So this is the hexagonal structure. Hexagon is present, hexagonal shape is present there. This is the first layer, one layer, and how the layers fit together into the graphite you can see here. Graphite is a different form of carbon that conduct the electricity because carbon atoms are arranged into the different way. They are arranged into the hexagonal sheets that are present there. So what will happen, just because of each carbon atom is bonded with only 3 more carbon atoms, so one free electron is present in with every one carbon atom. So electrons can move here. Electrons can easily move between the layers that are present there. Each graphite is a 2-dimensional giant molecule. Within these layers, each carbon atom is bonded to 3 more carbon atoms by the strong covalent bonds. Between these layers, there are weaker forces of attraction. These are the forces of attraction between these, and electrons can easily move in these layers. So layers can able to slide over each other. This means graphite feels slippery and also can be used as a lubricant. Graphite is also used in the pencils. Thin layer of graphites are left stuck to the paper when we write with the pencil. So this is the most distinguished property, that these electrons can move between the layers. These layers are present there, electrons can move easily carrying the charge, so graphite can conduct electricity. Carbon in the form of graphite will conduct electricity. Carbon itself is a non-metal, diamond is a non-metal, but graphite is a metal. So this is the allotropic form of the carbon in which electricity can be conducted as electrodes and for the brushes in electric motors. Graphite is used. Graphite is in the dark gray or shiny solid. Graphite is soft. The layers can easily slide over each other, and it also has a slippery feel. So it is used in the pencils and also for the lubricant. This is the example of the graphite as a giant covalent structure. Next we'll move towards the silicon oxide. So this is the structure of the silicon oxide and the diamond. Sand and quartz are the example of the silica. The silicon oxide found in the quartz has a structure similar to the diamond. So in this structure, each silicon atom is bonded to 4 more oxygen atoms. Silicon oxide has the formula of SiO2. SiO2 is the formula of silicon oxide. So I have shown you here with the diamond, comparison of the structure of the diamond and the silicon oxide. In the structure of silicon oxide, silicon atom is bonded to 4 oxygen atoms, but each oxygen atom is only bonded to 2 silicon atoms. So that means silicon has a formula of SiO2. You can see here, this is the silicon that is bonded to 4. The red ones are the silicon and the blue or the purple ones are the oxygen atoms. So both the diamond and the silicon structures are rigid. There is a tetrahedral structure or tetrahedral geometry that is present in it. All the atoms in these structures are held together throughout by the strong covalent bonds. They have strong covalent bonds that are present in it. That's why they form the giant covalent structures. And one more thing about this, they both have a tetrahedral structure. Both diamond and silicon show the similar physical properties. They are very hard. They have high melting and boiling point. Silicon oxide, like the diamond, does not conduct the electricity because there are no free electrons to move in these structures. All the atoms are combined with each other, so that's why they don't have any free electrons that will be able to move to each other. So now this is all about the giant structures of the covalent compounds, of the ionic compounds. Next, I will show you, or we will discuss about the summary of the chemical bonds which we have discussed yet. So let's have a look at the summary of the chemical bonding in elements and in compounds. First of all, we have the elements that are present in our periodic table. These are the elements that are present in our periodic table, and these elements are classified into two groups. First, we have the metals, and second, we have non-metals. Metals have the metallic bonding. Metallic bonding is present in case of metals, and in case of non-metals we have covalent bonding. Covalent bonding is present within the non-metals, and ionic bonding is present with the metals and the non-metals. So in case of metallic bondings we have giant metallic lattice. With the metallic bonding we have giant structures. Giant metallic lattice are present there, and in case of covalent bonding we have giant covalent structures. Giant covalent structures are present there. For example, as we have discussed, silicon oxide, diamond and graphite all are the giant covalent structures. So these are the classification of the elements in our periodic table. Metals as non-metals, metallic bonding and the covalent bonding. Next we have the compounds. In case of compounds, metals plus the non-metals make a bond, metal plus non-metal, and when metals and non-metals make a bond, that is known as ionic bonding. This is known as ionic bonding, and when non-metals and non-metals make a compound, that is known as non-metals with the non-metals. When they form the compound, that is known as the covalent type of bonding. So this is the summary of the chemical bonding. Metallic bonding represents the final type of bonding in the chemical elements in the compounds. We have discussed the following different types of bonding. Covalent bonding that occurs in elements and also in the compounds. Ionic bonding occurs in the metallic compounds, and metallic bonding that is present into the metallic bonding. These different types of bondings and also the nature of the substances by bond together are present there. So this is all about the chapter number 3, which is included in our chemistry IGCSE. So in today's lecture we have discussed about the chemical bonding. We have done with the ionic bonding, with the covalent bonding, and also with the metallic bonding. In that we have discussed about the different structures. In ionic bonding we have read about the ionic compounds. In the covalent bonding we have discussed the giant covalent structures and also the bonding in non-metallic elements, the single covalent bond, double covalent bond, and the triple covalent bond. In metallic bonding we have read about the physical properties of the metals and also the metallic structures and the giant metallic lattice that are formed with the different elements. So this is all about today. Hope you understand all this. If you have any question you can ask in the comment box. Okay, we will meet in the next video.